Hey all. In this tutorial, what we'll do is it's setting up a CI/CD pipeline in GitHub Actions. So first of all, what's the purpose of CI/CD for machine learning? So CI and CD are basically very common practices that are used in software development and to automate the process for integrating code changes, testing them, and also deploying the application quickly. Uh, Uh, let me summarize the advantages with CSCD for machine learning. So one thing is it will automate training pipeline. So we can automatically retrain your models on new data with regular cadence. So second thing is it can able to allow us catches errors early. So we can able to run test checks for each code commit. Uh, that will help us to catch bugs, integration issues, and other various decreases in model performances. So third thing is reproducibility. So it will ensure that models can be rebuilt and also retrained exactly the same way, enabling reproducibility for results. Fourth thing is testing and monitoring. So it will allow us for automated testing of new models before deployment for checking for issues. uh, Faster iteration. So uh, new models or versions can be quickly retrained, tested, and deployed in an automated fashion with CI/CD. So there is no manual triggering, there is no manual intervention here. And last thing is scalability. So with the ML projects that grow in size and complexity, uh, managing this entire lifecycle manually becomes impractical. So CI/CD pipelines can able to provide these pipelines will provide a scalable solution that can able to handle large volumes of data, numerous models, and diverse dependencies while maintaining efficiency and reliability. In this tutorial, what I'll do is I'll walk you through the process of setting up of creating a CI/CD pipeline and optimizing this entire process. So what I will do is we'll set up a local repo with code files and data. So I'll go through a model development for random forest algorithm that able to classify different drugs. So I'll show you the data set that is from a Kaggle competition. After training, like what happens is we'll entirely automate the process for retraining based on few triggers in GitHub Actions. So we'll automate this entire evaluation process using CML. What and we'll From training to evaluation, the entire process will be automated using GitHub Actions. So all you have to do is just push a code to your GitHub repo, and within like 2 minutes, this model will be updated, and it will have some bunch of different tests that will help us to finally deploy this model. So yeah. This is the data set that I was referring to. This is a drug classification from the Kaggle competition. So in this data, the target feature is drug type. So there are multiple levels of drug types, and the different features are age, gender, blood pressure level, and cholesterol level, and also sodium to potassium ratio. So I'll use this data set to train a random classifier model and help set up the GitHub actions. So let's start. I have actually wrote the code. I'll just quickly go through the explanation here. So first of all, like what we'll do is we will create these four folders. This is just for the organization, code organization. The first one is app. So just keep it app. I'll come to that. Second is data, where I will load the drag 200, the data set that I just mentioned on the Kaggle. Will upload here. And the third is model. This evidently and prefect is for another tutorial that I'll be entirely keeping this repo link in the YouTube description. So don't worry. Like about the model, this will actually save the model files and results. This will save the metrics and also results in like if you need any PNG or .txt files, this will save in that. So let's go through what is makefile. So makefile is it's just a simple text file that contains like set of rules that needs to be followed while building while running this automation tool. So first thing is install. So what it does is it basically this install command will install upgrade pip and install this requirements.txt. So let me go through this requirements.txt. So make these files also just copy and paste into your code files. So these are the various libraries. Pandas is for loading and loading the data sets. sklearn is where I'm going to use the random forest model. Matplotlib is for plotting. Scops is for saving the model, and black is a code formatter, so that you'll be needing. Let me go through the make file again. So here, whenever any code is pushed, I'll be formatting that code using black.py, and I'll be running the train command, and then I'll be doing the evaluation. So these are the set of rules that I'm making with a makefile. Let me go through in detail for the train.py. So these are various libraries that we'll be needing. So like I said earlier, for data manipulation, pandas, and sklearn for model selections, and various other functions that I'll go through when I come to there. Matplotlib for the plotting, and sklearn metrics for confusion matrix display, and scops to save and dump the model. First, what we'll do is we'll load the model using pandas.readcsv. So this is the data folder that consists my data, and I will be converting this into pandas data frame, and I will be assigning x and y as this. So drug.values will be my y, and x is I will be dropping the drug column from my data set. So I basically I have splitted my data into x and y, and again using train test split from sklearn with a 30% test size for 30.3. So that means the entire data set 30% will become my test data set, and 70% is my train. I have basically categorized train and test data set, and now what I will do is uh, I am going to pre-process the columns. So what I will do is uh, so for categorical columns that are basically age, columns that are gender and cholesterol level, I will be converting them into numerical codes here. And for the numerical columns, wherever there are missing data, I'm replacing with a median. And for also numerical columns, I'm scaling it down, scaling them the entire feature to a mean of 0 and standard deviation of 1. And I am actually calling ML pipeline here. So what it does is it creates a complete ML pipeline that preprocesses the data. So that calls this preprocessing function, and also that trains the random forest classifier. So when I call dot fit, so this is what it does. First it will preprocess, and then it will build the model. And now I'll make a predictions on the test data, and I'll compute the accuracy score and F1 score, and I'll be printing into the into the console here. And what I'm doing is I'm writing these files into metrics.txt, along with I'm plotting the confusion matrix, and saving this plot to into results folder. So results folder will for one run every time there will be two files that will create, metrics.txt and results.png. Finally, I will be saving this model into model folder. So using scops library. So if you run this command, you can able to see the model will be saved into the model folder dot scops. Yeah. So till now, what we have done is we have a data and we have code files, and what I'll ask you to do is commit those codes and push into your GitHub repo. So once you push into your code, you will see something like this, your folder structure. So train.py is the main code that we have just gone through, and requirements.txt contains all the dependency libraries, and we have like model and other files. So now what I will do is I'll ask you to go to here and set up on click on this link. So this will help us set up the GitHub workflow. Go to into actions, and like you will actually, you might, when you're starting, you might not see exactly like what I'm showing here. So you might be seeing something like get started with GitHub actions, and it will ask you to click on this set up a work for yourself. So click here, set up a work for yourself. So what you will be taken to this code editor. So where you will be writing this workflow instructions, what is defining the workflow. So I'll tell you another method. What you should do is you should come to your main repo, and you do this. So create a .github folder and /workflows, and create the ci.yml file, and just copy this code from here to into from my report into your, and I'll go through this code bit by bit. Okay. So this is the name. So what it does is it actually names the GitHub Actions workflow, and so this is like a standard template here. So uh, when this workflow will run is when there is some push to this main branch, and when there is a pull request from your main branch. So this workflow will run on these commands. You can actually set up multiple things when somebody commits to some other branch and all, but this I'm just showing a simple example for you. And now then once this is set up, so it will run on Ubuntu latest. And what it does is it will actually check out the file. So this is basically we're setting up the CML file. So this is CML, full form is continuous machine learning. So we are actually setting up this file. Now uh, it this actually sets up the CML file, and first it will install the packages. So this is for installation packaging. What it will do is it will run make install. If you recall, when we defined the make file, you can go and see this is what I'm calling as install. So make install means this entire commands will be run. So that is it will upgrade the pip and install requirements.txt. Let me go through the C file again, and then it will when after this step it will do go and do the format. And I'll show you format is it will just it will edit the it will do the code formatting. And now when I call the train, it will run the train.py. So this is where the train.python dot file will be run. And then the next is evaluation. So it will run an make run will run an evaluation. But the thing is, there is one actually step that I added in this code. If you see, it actually when some when I'm it's actually it will be parallelly updating another branch here. So there is something called branch. So when I'm pushing to main, so it will everything will be automatically run and added to the push to the branch. So this branch is a new uh, so update is a new branch that I've added. And that will actually help me recognize who is the user. So if this repo is shared by multiple people, who is that user who pushed the changes to my pipeline here. So this is the code. And something also you can set up is like uh, you can actually if you do this when you're adding this email, so it will when something is pushed, the pipeline will run and the train will run, and it will log all the results, and the results will be mailed to this email ID you can see here. Now I'll show to you how it works. So once you have committed this ca.yml file into your GitHub repo, so basically what it does is whenever there is any push that happens to the main branch, or whenever any pull request that is created to the main branch, this workflow will trigger and it will start running formatting, installing formatting, and then training the model, and then updating the results. So now what I'll do is I'll show you the how the workflow will work. So I'll just modify the code. Like I'll write a comment, and if I just control S, say it will show as my code is modified. Now I will go and push this changes to my GitHub repo. So I have added Git. I have committed this code. Now what I will do is I will push origin main. If I do this, now I'll go to my GitHub profile, and I will come to here. I'll go to my repo, and while it's being pushed, you can see something is running. So if you can click on this, you can see some checks are happening. So that means the pipeline is running. And if you go to the details, so this is what is happening. It's setting up job, the checkout action, and then it is setting up the CML, and then it's installing packages, because install is the next flow after checkout. It will install all the packages, and uh, then it will go to format, train, it will evaluation, it will update the branch, and then it will do the post on actions. So it will take some time. So this is how my continuous integration is being set up. When someone is pushed to push or create a pull request, this pipeline will trigger, and it will run these branches, and now the job is completed. So now the build is completed. So now what I will is I'll go to the summary, and you can see that build is success, and the total duration it took is 56 seconds. So it depends on the model. Like if the training is like if the data set is very huge, this entire duration will take a lot of time. Now I'll come back, and so you can see that uh, if I go to into my actions again, here you can see my history. So this is what has happened. These many times it has run. So 1 minute ago, 5 minutes ago, 7 minutes ago, like that. So basically that's it. So this is how I can able to actually set up the continuous integration with GitHub actions in with, for an ML model. So that's it. Any questions, reach out to me. I'll post my repo link and also the code, the Kaggle link into the description. Stay tuned.